Hello, welcome to week 8, which is week 12 of the coronavirus shutdown. And yeah, the nice thing about technology is, as you can see, I'm sitting in my, in my beach house in Florida and watching the waves come by. So anyway, hey, let's get into this. Let's get through this very quickly. I'm going to share my screen, which is, I want to share this. This is what it looks like. A lot of you are just kind of jumping to the homework. Please don't. You're getting bad grades. You're going to go to, first of all, you go to Files. And then this is Classwork 8, which is week 12, arc length. And you're downloading these 3 files right here. Arc length, the first one, Classwork 8, arc length. That's what we're going to be working on. You're going to work along with me. When you're done, do the additional practice, and then you can check your answers with the additional practice. And of course, I believe this is what it looks like when you have it. This is the video that you're watching, and then this one right here is the solutions to the additional practice. Okay, I'm going to stop sharing now. I'm going to go now. I'm going to, here we go. Arc length. We're talking about arc length, and you kind of have an idea of what arc length is, but we're going to give you more specifics and talk about how to solve for it. Okay, so we're going to start off. Arc length. The circumference of a circle. We know the formulas are C equals 2 pi r, and C equals pi times diameter. Now, a couple of quick definitions. The central angle or arc angle is the angle whose vertex is the center of the circle. Right here, this is the center. This right here, this is my central angle. You know that already. Now, the length of an arc is, this is what we're going to deal with today. Arc length, the length of the arc, is the partial distance. I'm having a hard time spelling. Partial distance around the outside of a circle between 2 radii. Partial distance around the outside of a circle between 2 radii. Okay. Well, let's deal with the same central angle. It's kind of the same. The arc length, these are 2 radii. This is the arc length that we're dealing with, okay? You kind of have a rough idea of what it is and how to do it, but we're going to put some more specific information into it now. Okay, determine the distance around circle O. Here's the distance around, which is the circumference. Leave your answer in terms of pi. I'm leaving in terms of pi for ease of use. Circumference, I have my radius is 12, is equal to 2 pi times 12. So that means my circumference is 24 pi inches. That's the distance. If I start at C and walk all the way around, I would walk 24 pi, which is roughly 70 or so inches, somewhere right around there. I don't know. Okay. What is the length of arc BC? This arc, what's the length of this arc right here? Well, the central angle is 90 degrees. 90 degrees, you know that, that's a quarter of a circle. So 1/4 of 24 pi. The whole thing around is 24 pi, a quarter of that. So the distance is 6 pi. If I walked completely C all the way around to C, I'd walk 24 pi. But if I start at C and end at B, I'd only walk 6 pi, which is a quarter of the circle. All right, now let's switch a little bit here. We've got circles, central angles P and O have the same measure. They're both 90 degrees. So arc angles, so the arc angles ED and BC are the same. So the central angles are the same, the arc angles are the same. We talked about that a long time ago. Are the lengths of ED and BC the same? Think about this for a second. This has a 12-inch radius, this has an 8-inch radius. Are these arc lengths the same? I'm going to say, no, they're not. Okay, they're not the same because this is a quarter of a bigger circle. This is a quarter of a smaller circle. A quarter of a bigger circle, obviously, is bigger than a quarter of a smaller circle. Which one is longer? I want to say arc BC, and we say arc BC with an arc over it, is greater than arc ED because it's a bigger circle. Okay, let's go on to, let's solve some problems, okay? When we're dealing with arc length, we're going to set up a proportion every single time. Partial over the whole is equal to the partial over the whole. We're always dealing with degrees, and we're always dealing with the central angle. And S, I'm calling S in this case, it's probably the last time we will use S, but S is the arc length. And theta is a Greek letter, kind of like pi is a Greek letter, delta is a Greek letter, theta is a Greek letter. That's what we call a variable for angles. So theta, the central angle over 360 degrees is equal to the arc length over the circumference. So we're always going to set up a proportion, and every time we set up a proportion, 360 degrees goes down in the left-hand corner. The central angle goes above it, the upper left-hand corner, the arc length goes here, and the circumference goes here. And I'm going to tell you, I can ask you, what is the central angle? What is the arc length, and what is the circumference? I'm going to have 3 different problems like that. Okay, so find the length of arc AC in the diagram below. So AC, round your answer to the nearest 1/10 of an inch. So we're going to set up a proportion. Theta over 360 is equal to the arc length over the circumference. I'm going to automatically start off and saying my circumference is equal to 2 pi, and the radius is 8. So my circumference is equal to 16 pi. Let's set up a proportion now. 360 always goes down here. My central angle, so the top left-hand corner is the central angle. My central angle here is 135, is equal to the arc length, that's what we want to find, over the circumference, which is 16 pi. Let's cross multiply here. 360 times x, I can do that as 360x, is equal to, and then this right here, 135 times 16 pi. To get x all by itself, I just have to divide both sides by 360. I'm only dividing by 360 one number, so I can do this all in one fell swoop, okay? So in my calculator, I'm putting 135 times 16 pi divided by 360. And my answer is 18.849, da-da-da-da-da. So x is equal to 18.849, da-da-da-da-da. Round your answer to the nearest 10th. The nearest 10th, 8, and this 4 tells me you keep it the same. So arc AC is equal to 18.8. Okay, that was easy enough. And really, this is what we're going to be doing the entire time, is just setting up a proportion, cross-multiplying, and solving. Number 2, in the circle B below, the length of arc AC is 11.2 inches, determined to the nearest 1/10 of a degree, the measure of angle B. So this is 11.2. We want to find my arc angle. So once again, circumference, C equals 2 pi times 10 is equal to 20 pi. I figured out my circumference is 20 pi. Let's set up my proportion. 360 always goes down there. My arc angle, or the central angle, is right here. In this case, it's x. My arc length is 11.2, and my circumference is 20 pi. Let's make that in there, 20 pi. I'm going to draw this, and we're going to cross multiply. Remember last time, this is where my x was. Now this is where my x is, but you guys are smart enough. You know better than that. You know how to handle this. Cross multiply. 20 pi x is equal to cross multiply 360 times 11.2. I want to get x all by itself, and there's a 20 pi over here, so I'm going to divide by parentheses 20 pi parentheses. Remember, when we're dividing by 20 pi, don't do this divide by 20 pi. You have to divide by parentheses 20 pi, close the parentheses. In my calculator, using calculator voice here, we do 360 times 11.2 divided by parentheses 20 pi, close the parentheses, and I get 64 x is equal to 64.1712 dot 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 dot, and we want to find to the nearest tenth of a degree. Angle B is equal to, nearest tenth is a 1, the 7 tells me 64.2. Hey, look at that, we're almost done. We've got pages 3 of 4 done. Page 3, we've got to do number 4. The problem with page 4 is that there's 4 problems on it. Uh-oh, we have to do one more than we did. Actually, twice as many as we did before. But we're smart enough. We can persevere. The length of intercepted arc TP is 10 feet. So there's 10 feet. The measure of angle TOP, so TOP, 53 degrees, to the nearest tenth of a foot, what is the length of the circumference of circle O? So I want to find the circumference. Set up my proportion. 360 goes down here. My central angle, 53. My arc length, 10, over my circumference. Cross multiply. 53 times x is equal to cross multiply 360 times 10. I want to get x all by itself, so we'll divide both sides by 53. And let's do 360 times 10. Oh, I could have done that. That's 3,600. Divided by 53. And I get x is equal to 67.9245 dot, 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 to the nearest tenth of a foot. There's the 10th place. 2 tells me to keep it the same. My circumference is equal to 67.9. Okay, this is an excellent time to talk about the magic number of the week. So this week's magic number is 456, 456. There's going to be a problem on the homework. It's going to ask you, what is the magic number? It's going to be the easiest question of all. You just say, hey, it's 456. No work involved. Okay, again, the magic number, 456. Let's move on. Number 4. The length of the intercepted arc of a circle, or what is the length of the intercepted arc of a circle when the central angle is 138 degrees and the radius is 21 feet? Round your answer to the nearest foot. Okay, we're going to set up a proportion, but the first thing I need to do is c equals 2 pi. My radius is 21. C is equal to 42 pi. Okay, good. My proportion, 360, goes on the bottom. My central angle here, which is 138. What is the length of the intercepted arc? So my arc length is there, and my circumference is 42 pi, goes on the bottom. Cross multiply. 360x is equal to cross multiply 138 times 42 pi. I want to get x all by itself, divide both sides by 360. Divide both sides by 360. X is equal to, calculator voice, 138 times 42 pi divided by 360. And I get x is equal to 50.5796, 5796, da, 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 da. Round your answer to the nearest tenth. This is a tenth. We rounded, this tells me to go up, so it is 50.6, my answer. So no picture, no problemo. Number 5. 5 and 6, 2 questions left. A circle with a 7.5-foot radius intercepts an arc that measures 8.5 feet. Determine to the nearest degree the measure of the central angle that intercepts this arc. So if I give you the radius, once again, let's find my circumference. C equals 2 pi 7.5. And we know 2 times 7.5 is 15 pi. Let's set up my proportion. We know that 360 always goes on the bottom. Let's see, determine, we want to find the central angle. So the circle with a 7.5-foot radius intercepts an arc that measures 8.5 feet. So my arc length, and then my circumference is 15 pi. Let's cross multiply. 15 pi x is equal to 360 times 8.5. I want to get x all by itself. I'm going to divide by parentheses 15 pi, parentheses, divide by parentheses 15 pi. I've run out of room, so I'm going to have to go up here. X is equal to 360 times 8.5 divided by parentheses 15 pi, close parentheses, and I get 64.935, 64.935, dot, dot, dot. Nearest, determine to the nearest degree, 64. This 9 tells me 65 degrees. All right, last problem. Central angle AMR measures 74.5 degrees in circle M. The length of arc AR is 21.45 centimeters. What is the circumference of circle M? Round your answer to the nearest hundredth of a centimeter. Remember, central angle AMR. If I was to draw a picture of this, here's my, whoops, that's a pretty good circle, isn't it? Good enough. M is a vertex, A, M, R. Central angle is 74.5. The length of arc AR, the length is 21.45. What is the circumference? You want to find the circumference, okay? So that's what it looks like. The reason I drew this picture is to show you that angle AMR, the arc is going to be AR. It's going to be between A and R, okay? Let's set up my proportion. We know what goes down here. Boy, even Lorkowski could tell me what goes down here. 360. My central angle, 74.5, is equal to my arc length, 21.45, over my circumference. Oops, we don't want that to be a triangle. We're going to draw this, and we're going to cross multiply. 74.5x is equal to cross multiply 360 times 21.45. I want to get x all by itself. Divide both sides by 74.5. Divide both sides by 74.5. My calculator, 360 times 21.45 divided by 74.5, and I get an answer of 103.6510. X equals 103.6510, da 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 da. And then we want to round your answer to the nearest hundredth, 2 decimal places. 65, the 1 tells me keep it the same. So the circumference of this circle is 103.65. All right, life is good. Let's go back here. You get to see me in my beach house. Actually, you get to see the view from my beach house. This was all about arc length. I hope you understood it. You know what's going on. After this, do the additional practice. And then once you've done the additional practice, check your answers with the solution. And if you haven't solved it, or I'm sorry, if you have any questions at all, you can watch the video of me solving it. And the other option is you can contact me. You can send me a chat. You can send me an email, and in the assignment, it gives you my Google Voice number. Remember, once again, the magic number of the week is 456. Until I see you again, have a great weekend, or have a great week. Bye, Nair.